Hello, everybody. Today I'm going to be going over your lab 3, which is bioavailability of iron. So this week's lab is pretty simple, but you are going to be writing an actual report this week over the lab. So I want to give y'all an idea of exactly what you will be doing this week. So in this introduction here, it's talking about how iron is an important part of our diets, but it can have issues being absorbed in the small intestine. So what happens is you have solid iron that gets dissolved in your stomach acid at a pH of 2, and it turns into this iron 2 plus ion that can be absorbed whenever it reaches your small intestine. But an issue is that iron 2 is only favored at low pHs, like in your stomach, where it's not quite absorbed. But when it goes down to your small intestine, where it can be absorbed, your small intestine has a pH of 8. And at pH of 8, your iron 2 gets oxidized to iron 3. And iron 3 can do this right here, where it reacts with hydroxide to make a solid. And a solid cannot be absorbed by your small intestine. So, the way our body combats this is through several different vitamins and minerals that we take in our daily diet. These vitamins and these molecules can ultimately prevent this iron hydroxide formation and keep the iron in a aqueous state that can be absorbed in your small intestine, even though it is at pH of 8. So what we're going to be doing in this lab is we are going to be testing several different food additives. Here are the additives right here. And we're going to see which of these allow our iron to stay aqueous even at high pHs. So the first part of this experiment is we're going to have a control. We're just going to have our iron dissolved in acid at a pH of 2, and we're going to react it with sodium hydroxide, and you'll be able to see the iron precipitate out once your pH has passed 8. So this first part will serve as your baseline. Part 4, you are going to be assigned 3 additives right here to add in to your iron solution, and then you're going to add your sodium hydroxide again, and you're going to see if iron forms or not, or if everything stays aqueous. And you'll do that for all 3 of your additives. Make sure that you're taking observations about color changes, because let's go over to your LabFlow. This is what you're going to be expected to put in for each of your additives. So you'll have a substance D, which is just going to be a number. So like ascorbic acid is going to be 1, oxalic acid will be 2, tannic acid will be 3, so on. I'll have the substance IDs listed in lab. Your initial pH, all these should be a pH of 2, what they look like initially, and then your observations as you go on. So does it become cloudy? Does it look the exact same? We need to know what is happening as you're adding drops, the number of drops you add total, and then the final appearance of the solution. So you're going to have to do that for each of your 3 additives. And after that, you're done for the lab. But you will have to wait around because ultimately, everyone in the lab will collectively do all of these additives. So while your group will only do 3, another group will do a different 3, another group will do a different 3, and so on. And so you'll have data for all 11 of these additives. So you're ultimately going to have to stick around until we have data for all 11 additives. But it's a pretty straightforward lab. You just have to know what's going on so you can write a report. So let's talk about your report a little bit. I'm going to pause real quick. So your report this week, you're going to have 2 questions, and then you're going to write your 7-section report. So your first question is asking you to consider the method you use to determine the volume of your sodium hydroxide added, and whether that is an accurate method of adding small volumes. So the way you're going to be adding sodium hydroxide is using a dropper. So what this is asking is a dropper going to be consistent in the amount of liquid it gives? Um, is the drop size going to be the same every single time? So consider that. And the other question is asking about pH paper and for you to estimate, for you to compare the estimation of pH between a pH paper and a pH meter. So a pH paper, obviously you have a spectrum of colors. I can actually pull that up real quick. So pH paper, you have a spectrum of colors like this, where a dark red is a pH of 0 and a dark blue is a pH of 13. And notice here, these are only increments of 1. So how many significant figures do you have? And what's going to be the uncertainty here? Like if you see this color, are you certain it's 6, or is it could be a little bit less than 6 or a little bit more than 6? So consider the fact that these are in increments of 1. So what do you think your uncertainty is for your pH paper? And it's asking you to also compare that to a pH meter. And a pH meter commonly goes out to the hundredths place. So which one of these is a better estimate and has more significant figures? So moving on to your report, the first part of your report is just a title. You get a full point if you can give it a scripted title. Bioavailability of iron is non-acceptable title. That's an easy way to lose half of the points on this question. A descriptive title is one in which I know what the goal of the lab was. So you should be putting in keywords about what you were exploring in the lab. And a title can be a little long. It doesn't have to be short and succinct. Scientific titles tend to be a little long. So just have a title that describes what the objective of your lab was. Next, we have introduction. So you should be talking about the background and you should make a hypothesis. So the background is going to be what I was just talking about earlier about how iron is absorbed in the small intestine at a pH of 8, but it has issues being absorbed at that pH without other things to keep it aqueous. So you should cite something talking about the background of this lab. You can use the lab manual, that's perfectly acceptable. And you should also have some sort of hypothesis. So maybe look at all the additives and take a guess as to which additive you think is going to be able to keep your iron aqueous or not keep it aqueous. So make sure you have both the background and a hypothesis there. If you don't have a hypothesis, you won't get full credit. Next is your method section. A method section is just talking about what you did at each step. So in a sense, it's like your lab manual here, except you have to paraphrase into words. Do not list it out with numbers like this. It needs to be in paragraph form, and that will be a good method section. So make sure you're not just copying and pasting this and plugging into LabFlow. I need a paragraph form of what you did in this lab. Results, you'll want to have a table. Let me pause real quick. You'll want to make a table probably very similar to this. Make sure you make your own table, one that's outside of LabFlow. You could also maybe make a graph based on the number of drops that each substance used, seeing if there's any correlation between the substances that allowed iron to stay aqueous and the number of drops that were used. That's another possible figure you to make. But for results, you need some sort of figure that shows what you did in the lab that you made. Next, analysis. So you need to be relating your background to the results that you just made. So there needs to be some interpretation of what a clear solution represents and what a solution that has precipitate represents. And you need to talk about that in your analysis and your discussion. You also have some questions over here at the bottom of the procedure that you can use. You can talk about all of these things here and that would make a good discussion section. You don't have to discuss every single thing here, by the way. Just if you don't exactly know what to discuss, you can pick one of these topics, and that will help you write a discussion. And then finally, your conclusion, you need to go over what you did in the lab. It's a summary of everything in the paper. So just give a brief summary of what you did. And then finally, references. You are expected to have a couple references. So I expect 2 references. If I only get 1, I'm only going to give you half credit. So you can always reference the lab manual as one, but you should look around and try and find some other reference. Maybe you can look up some of the additives to see if they have been any studies that show that one additive helps with iron absorption or another additive doesn't. You can put that in your introduction. You can also put that in your discussion. Those are usually the sections that are best for referencing. And make sure that if you reference something, that you have an in-text citation. If I see references at the end and you don't have any in-text citations, I will also only give you half credit for that. That is the other half of doing a reference is that you have to do an in-text citation as well. So I hope that gives y'all some idea of what I'm expecting on this lab. Uh, Try and do your best to have a good lab report here because the better you do on this, the better you're going to do on your final lab report, where you are again going to be writing a full lab report like this, except it's going to be worth more points than what this lab is worth. If y'all have any questions, feel free to ask me.